In this question, you are asked to find all the complex cube roots of the complex number -8i, and you're also directed to leave your answers in polar form with the argument in degrees. So the first thing you want to remember is if you are given a complex number in rectangular form, x plus yi, and you're asked to find the roots, the first thing you're going to need to do is switch that complex number to polar form. So you're going to need to write it as r times the cosine of theta plus I times the sine of theta. And then once you have it in that form, then you can use de Moivre's theorem to find the three complex roots. So the first thing I need you to recognize when you're looking at -8i is it is in rectangular form and the real part is 0. So this can be written as 0 plus -8i. And if you take a moment to sketch this in the complex plane, you should be able to easily recognize what r and theta are. So remember, x is the real part and y is the imaginary part in the complex plane. So for this complex number, x is 0 and the y is -8. So this point down here represents 0 minus 8i. So you need to switch this to r and theta. Now recall that r is the absolute value of z, also given as the square root of x squared plus y squared. But before we even plug in the number, just realize that that is the distance between the origin and z, and distance is always considered to be a positive number. So you may recognize in advance that this distance here for r is positive 8. But if you don't, you can still use the formula, and if you plug this in, you would just have 0 squared plus -8 quantity squared. You'd still have the square root of 64 and get that positive distance. As far as the angle goes, if you have sketched this in the plane, you should easily be able to see that in standard position this angle is 270 degrees. So we can rewrite this complex number in polar form and write it as 8 times the cosine of 270 degrees plus I times the sine of 270 degrees. Now, once you have that in polar form, now we're ready to apply de Moivre's theorem. So the formula to find roots using de Moivre's theorem is written as follows. We have z sub k is the nth root of r times the cosine of theta over n plus 360 degrees times k over n plus I times the sine of theta over n plus 360 degrees k over n, and you apply this formula in this case for k equals 0, 1, and 2. Because we are finding the cube roots, there will be 3 unique complex roots, and we're going to find them by applying k is 0, k is 1, and k is 2. But before we do that, we're going to rewrite this formula with our values of r and theta. So this will be the cube root of 8 times the cosine of 270 degrees over 3 plus 360 degrees over 3 times k plus I times the sine of 270 degrees divided by 3 plus 360 degrees divided by 3 times k, again for k equals 0, 1, and 2. And one more time, we're going to simplify this before we plug in the values of k. The cube root of 8, of course, is 2, and this is going to be the cosine of 270 degrees divided by 3 will be 90 degrees plus 360 divided by 3 will be 120 degrees times k plus I times the sine of the same values. This will be 90 degrees plus every 120 degrees thereafter for k equals 0, 1, and 2. So that is the formula that we're going to use for de Moivre's theorem. And now to find the 3 roots, we label them as z sub 0, z sub 1, and z sub 2. So for k equals 0, the first root is going to be 2 times the cosine of 90 degrees. When you let k be 0, it'll just be 90, plus I times the sine of 90 degrees. For the second root, we let k be 1, so we have z sub 1 equals 2 times the cosine of, and this time, if you let k be 1, you'll have 90 plus 120 degrees, so that is going to be 210 degrees, plus I times the sine of 210 degrees. And for the third root, you let k be 2, and if you let k be 2 in this formula and add 120 degrees again, 120 degrees times 2 will be 240, and 240 plus 90 will be 330 degrees, plus I times the sine of 330 degrees. So these are the 3 unique cube roots of negative 8i, and that is leaving your answer in polar form. If you had been asked to switch this to rectangular form, what you would have done is just evaluated these expressions, finding the values for x and y.